Yo, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And in today's video tutorial, we are going to be taking a look at selection sort algorithm. So yes, this is a sorting algorithm as the name suggests, and if you don't know what sorting algorithms are, in the previous video tutorial of this DSA playlist, we've discussed in detail about what are sorting algorithms and why do we need them. So I'll drop the link of this entire DSA playlist in the video description. If you want, do check it out. There are other topics in this entire playlist as well. And with that being said, let's get started with today's topic. Now we'll divide selection sort algorithm topic in two parts. So this is going to be part 1. So in this video, we'll take a look at the theory, the working, and we'll also see the algorithm. And we'll take a look at the diagrammatic representation of the working so that we can step by step dry run the algorithm as well. So majorly you'll understand the entire working over here, and in part 2, that is in the next video, we will write a program in C++ to implement the selection sort algorithm. So we'll convert the algorithm into the implementable coding part, okay? So let's start off with part 1. Let's try to quickly take a little bit of theory and understand selection sort algorithm. So selection sort is a sorting algorithm, obviously the name suggests, and it is specifically an in-place comparison sort. So what happens is you select a place and you compare all the other values to that place and sort and make the swapping accordingly. So you'll understand that more when we actually go ahead in the working. You can just note down this keyword, in place comparison sort, okay? Point number 2 says it has O of n square time complexity. Now for the time being, just note this, do remember this point. We still have to discuss time and space complexities and the asymptotic notation concept in detail. We will do that further when we understand these basic sorting algorithms. So I have a separate dedicated video for time and space complexity and that asymptotic notation concepts. So you'll find that in this DSA playlist. If not, just subscribe, you'll get notified whenever I upload that video. So moving ahead, the algorithm divides the input list into two parts. So the part 1 is the sublist of items that are already sorted and which is built up from the left to right. And the second part is the sublist of items which are remaining to be sorted that occupy the rest of the list. Now right now you will not clearly understand this point, but when we go ahead and see the working, you'll understand it very well. So just hold on for a few minutes and you'll understand this. Next is initially the sorted sublist is empty and the unsorted sublist is the entire input list. And last point says the algorithm proceeds by finding the smallest or the largest, of course depending upon the sorting order, smallest or the largest element in the unsorted sublist, exchanging it with the leftmost unsorted element and moving the sublist boundary one element to the right. Again, these points will not really make sense until and unless you actually see the working. So as you can see, we have an integer array over here. So array data structure with a size of 5, and it has 5 integer values which are not really sorted. They are in random order, right? So we have the diagrammatic representation over here, index position 0 to 4, and their corresponding integer values. So let's try to apply this selection sort and let's see how it looks like visually in different steps, okay? So when you apply selection sort, the first step is find the minimum element and place it at position 0. So when you apply the selection sort on this array, initially in step number 1, we select the 0 index position, okay? And we check all the values and we compare it with this value. So we will start off from 1, we will check the value at index position 125. If 25 is smaller than the value at position 0, we will make the swap, right? Similarly, again we will move ahead and take this index position, again compare it with the swapped value, and if 12 is less than the value which is present at index position 0, we will again make the swap or we will not make the swap. Now depending upon what you want, whether it is ascending or descending. So in that way our logic will go ahead, and ultimately at position number 0, we will have the smallest value, right? So if you apply this in the first step, find the minimum element and place it at 0 position. If you compare the entire array, the minimum value is 11. So this will be ultimately swapped at position 64 or position 0, okay? So if you see after step number 1, on the left hand side, we have the very first element of the sorted subarray. So 11 is placed over here, and on the right hand side, we have the unsorted subarray. So these are what the points were saying. We make two parts of the entire list or entire array. The first one is the sublist of items already sorted, which is built up from left to right. So starting from the left, we will slowly move ahead, and in the next step, we will select position number 1 and bring the smallest value at position number 1. Okay. So let's see step number 2. So there you go. At step number 2, again we will find the minimum element and place it at position number 1. So if you see in these 4 values, that is in the unsorted subarray, that is this subarray, the smallest value is 12. So now the 12 value is being kept at position number 1, index position 1. And after that, the sorted subarray increases in size and we have unsorted subarray over here. So I hope you are getting it. Similarly, we will find minimum element and place it at position 2, 3, and the last one will automatically get sorted by default, right? So let me show you all the other steps. So there you go. Find the minimum element and place it at position 2. So if you compare the minimum value in these 3 values, you can see 22 is the minimum one. So bring 22 at position number 2. And after that you get 3 elements in the sorted subarray and remaining 2 in the unsorted one. Lastly, you find the minimum element and place it at position 3. Out of the 2, 25 is obviously minimum only, so you keep it as it is and the last one gets sorted by default. So now you have a complete sorted array using selection sort. So the reason why it is called selection is because you select index position at every step and you bring the minimum value at that index position from the entire array or list. Okay? And that's why it is called in place comparison sort. You select a place. So right now this is the place 0 position at step number 1 and you bring the minimum value at that position. Then you move that place 1 ahead. Now you are interested in position number 1. Then you are interested in position number 2 and here you are interested in position number 3. So now that you've got a basic understanding of how the algorithm proceeds or how the sorting works, the next question is how does the algorithm look like? Because we need the algorithm to convert it into proper C++ code, right? To implement it in the form of programming, you need a proper algorithm. So now let's see the algorithm and let's try to implement and dry run the algorithm by taking the diagram and this same example. Okay, so as you can see on this left hand side, we have the selection sort algorithm. Let me just mark it. Okay, so this is the complete algorithm. We are taking the same example of integer array with size 5 and the same elements. Now what we'll do is we'll go step by step and dry run this algorithm. Because if I just read it out, it will not make much sense. But when you dry run it step by step and calculate the values of the individual variables in this algorithm or pseudocode, then things will be more clear. Okay. So we have our array named ARR. So that's why name of the array. N is the size of the array. We know the size of the array is static, which is 5. So I've noted it over here. So if you observed in the previous slide or in the working explanation, we required 4 steps to perform sorting of an array with size 5, which means the number of steps required to sort using selection sort is 1 less than the actual size of the array, right? Because the last element automatically gets sort if the first 4 get sort, right? So if you sort 0, 1, 2 and 3, the last value obviously will be automatically getting sorted. So that's why the first for loop will run from I equals to 0, I less than n minus 1 and I plus plus. So what we are doing is we require those 4 steps, right? So just to show you, these were the number of steps that were required, right? 1, 2, 3 and 4. So these steps are repetitive iterations, right? So that's why we are using a for loop and we require 4 steps to perform sorting of an array with size 5. So that's why we are saying I equals to 0, I less than n minus 1. Now n is 5, so I should be less than 5 minus 1, that is 4. So I should be less than 4. So from 0 to 3, which is 4 steps, right? And then we have I++. I hope you know the looping concept and other basic C++ or any programming concepts. By the way, you can implement selection sort in multiple different programming languages. You don't need just one particular language. We are going to be using C++ in the next video, but you can also implement it in Java, Python or any other programming language. Okay. So this outer for loop over here, you can see is basically for these larger steps or larger iterations. So we have 4 major iterations. And inside that, if you go inside the for loop, if you see, we have multiple steps and we have some smaller for loop also. So this is the outer for loop and this is the inner for loop, because in every step, you also have to perform the comparison, right? So that comparison will happen in this smaller for loop, okay? In this smaller for loop. So the outer for loop is for these 4 major steps. The inner for loop is for the comparison and checking, okay? So let me just hide this again. Okay, so let's start off with the for loop because that is the starting point of this algorithm. So initially I equals to 0, right? So let me write I equals to 0 over here. Let me use another color. So I equals to 0. Is I less than n minus 1? N minus 1 we know is 4. So 0 less than 4, true. So now we will go inside the for loop. So the first statement here is min equals to I. So we have one more variable min which is keeping a track of the index positions. Okay, so right now I equals to 0, so this 0 is transferred into min variable. So again min will also have 0. So basically we are step by step dry running this entire algorithm to understand how it works, and we are using this array as an example. Okay, so moving on to the next step. The next step is the internal for loop or the smaller for loop, which is inside the larger for loop. So this is the smaller for loop. Now here we have j equals to I plus 1. You'll understand why we need that. So j equals to I plus 1. I value is 0 plus 1. So j becomes 1. Okay, we will note all the values over here and keep a track of these values so that you understand what is happening at every iteration. Now j is less than n. What is the value of n? 5. And what is the value of j currently? 1. So is 1 less than 5? Yes. So we go inside this for loop. Now inside this for loop what we are doing is we are checking if ARR of j is less than ARR of min. Now we know j is 1. What is ARR of 1? 25, right? So we are saying is 25 less than, what is min? You can see we have min as 0. So ARR of 0 is 64. Is 25 less than 64? True, right? So this is true. So now we go inside this if block, and inside this if block we have this one statement, min equals to j. So we are updating this min variable with the j value. J value is 1. So this 1 will be transferred inside min, and now the new min value is 1. Okay. So let me just erase this and update it with 1. Now again we are coming at end if. So we come outside the if block. We come at the end of the for loop, which is over here. From here we again go to the start. And now j plus plus happens. So now j becomes 2. Okay. Let's make it 2. Over here also 2. So j becomes 2. Is 2 less than 5? True, right? So we again go inside this smaller for loop. Now inside this smaller for loop we have this comparison if ARR of j. Now j is 2. The value at index position 2 is 12. So we are checking is ARR of j, that is 12 less than ARR of min. Now we just updated the min value as 1. So ARR of min, that is ARR of 1 is 25. So is 12 less than 25? True. So again we will update the min value, and now the min value becomes equal to j. What is j? 2. So min value also becomes 2. Let me update it over here. We come outside the if block, we come at the end of the for loop, and we again go to the start. Now again j equals to plus plus. So j now becomes 3. Is 3 less than 5? Yes. So we again go inside the for loop. Again the checking is happening. ARR of j. So j now is 3. Let me update it over here. What is ARR of 3? ARR of 3 is 22. Is 22 less than ARR of min? What is min? Min is 2. So ARR of 2 is 12, right? Is 22 less than 12? No. So now this if block will not be executed and this statement will not be executed. We come at end if, we come at end for, and again go to the start. Again j is plus plus. So j now becomes 4. Is 4 less than 5? Yes. So we go inside the for loop. Again a comparison is happening, and this time we are comparing ARR of 4. What is ARR of 4? 11. Is ARR of j, which is ARR of 4, less than ARR of min? Min is what? 2. You can see over here. So ARR of min, that is ARR of 2, is 12. Is 11 less than 12? Yes. So now we again update the min value. So min is basically keeping a track of the index position with the minimum value, right? So we transfer j, that is 4, into min. So let's update min. Min becomes 4. Again end if, we come at the start. J plus plus happens, and now j becomes 5. Now j becomes 5, but the condition becomes false, because is 5 less than 5? No, right? It is equal to 5, but it is not less than 5. So now we exit outside this for loop completely, because the condition has become false. So we come to end for, and ultimately we come at this last step. Now here one last check is happening if min not equal to I, because we have to swap the minimum element and the current element. Remember, I is always holding the current element. Okay. So current element is at the 0 position. Where is our min? Min is storing the value of 4. So min is over here. This is min. So here what we are doing is, if min not equal to I, what is the value of min? 4. What is the value of I? 0. So is 4 not equal to 0? This is true, right? Which means that this if condition is true. Min is not equal to I. So when it is not equal to I, we have to perform the swapping. And swapping is between ARR of min and ARR of I, which is ARR of min is this and ARR of I is this. So we have to do this swapping. So 11 goes to 64's position and 64 goes to 11's position. So this is basically step number 1 when I equals to 0. So after this first step, what will happen? We will get the result of 11, 25, 12, 22, 64. You can see 11 is being swapped with 64. So 11 comes over here and 64 goes over here. So this is step number 1. And at the end, after this swapping, you can see we come at the end of the for, and this end for is basically for the outer for. So now we again go back to this for, and now here I plus plus. So I now becomes 1. Okay. So now again this process will completely start for step number 2. So let's see how step number 2 goes. Okay, so I've just erased everything and I has now become 1. So I is 1. Is I less than n? What is n? N is 5. So we need to check I is less than n minus 1. So we need one step less, right? So 5 minus 1 is 4. Yes, 1 is less than 4, right? So now we again go inside the outer for. Now we change the min value to 1. Okay. So the new min value is 1. I value is also 1. Min value is also 1. So now we are more interested in index position 1. Okay. So 0th position is done. We've brought the smallest value at the 0th position. And now we are moving one step ahead. So we are more interested at index position 1. So now we will check all the minimum values and compare it with value which is placed at position 1. And the smallest value will bring to this position 1. Okay. So once this minimum value is set to 1, we will go ahead in the smaller for loop. Here we say j equals to I plus 1. What is value of I? The latest value of I is 1 and 1 plus 1 will become 2. Is 2 less than n? What is n? 5. 2 is less than 5. True. So we go inside this for loop. Now here we are checking if ARR of j. So j is 2. So ARR of j is 12. Now we have to check at this array and not this array because this is the updated array. So ARR of 2 is 12. Is 12 less than, what is ARR of min? Min value is 1 currently, you can see over here. So we are looking at this, which is 25. Is 12 less than 25? True. So now we update the min value. So min value also becomes equal to j. J is 2. So 2 is copied inside min. So min also becomes 2. Okay. We end if, we end for and come again back to the start. J becomes plus plus. The initialization only happens once. Now j plus plus, so j will become 3. Is 3 less than 5? Yes. So we go inside this for. J has become 3, so I'll update it over here. We say ARR of j. ARR of 3 is 22. Is 22 less than ARR of min? The new value of min is 2. ARR of 2 is 12. Is 22 less than 12? No. So we will not go inside this if, right? So this statement will not be executed. We will end if, we will end for, again come back. J plus plus, j becomes 4. J becomes 4 over here also. We are keeping a track of these variables so that we can dry run it very nicely. Is 4 less than 5? True. So we again go inside. Now we again check is ARR of j, which is ARR of 4, which is 64, less than ARR of min. ARR of min is 2, which is 12. Is 64 less than 12? No. So this statement will not be executed. End if, end for, again come over here. Now j value becomes 5. So 5 is not less than 5, right? So we exit outside this for loop, come over here. So at this point, now we again make a check. If min not equal to I, what is the value of min? You can see it is 2, right? So in the array, this is that index position. What is the value of I? You can see value of I is currently 1. So 1 and 2 are not equal. If they are not equal, we have to perform the swapping. So we have to swap 12 with 25 and 25 with 12. So at step number 2, these two values will be swapped and this is how the result will look like. So you can see 12 and 25 are being swapped. So again we will end this if, we will end the last for, that is outer for, and we will come back over here. I was 1, again I plus plus will happen. So I will now become 2. So again a check will happen. 2 is less than 4 only. So again this for loop will execute, and now I'm not going to continue this because by now with these two iterations, I hope you've understood how the algorithm is working and how the comparison is happening. Okay. If you're still a little bit confused, what you can do is you can pause this screen and you can dry run this code yourself. Just make a note of these 4 variables and go ahead step by step as we did, and ultimately you will reach at the final output wherein the array will be sorted in ascending order. Okay. So this is the final result that you will achieve, and then the condition will become false and we will exit outside the outer for and the algorithm will be stopped. Okay. So I hope you've got a very good idea about selection sort algorithm. We discussed a little bit of theory of selection sort. We saw the working also, and ultimately we also saw the algorithm. and we also dry run that algorithm so that we understand what happens step by step in the pseudocode of the algorithm. So that's it for this video, guys. I hope you understood what is selection sort and the working. In the next video, we will convert this entire algorithm into C++ code and implement it in a practical way. You can also use any other programming language, whichever you are comfortable with. We are going to be using C++. So thanks for watching, guys. See you in the next one. Peace.